recording? Yes, it is. Okay. Absolute value inequality. Chapter 6, Section 6. Now, inequality. Remember to flip the sign when you multiply or divide by a negative number. Remember that rule back when we did inequalities? Whenever you divide or multiply by a negative number, you have to flip the sign. Now, after you do that, you have to pretend the inequality symbol is an equal sign. You solve the equation just like that. But we have to have two cases. Okay? We still always have to have two cases. Case 1 and case 2.
Okay.
Okay, let's talk about these steps. Step 1, isolate the absolute value. We've already done that, right? You guys know that you have to get the absolute value by itself. Okay? Isolate the absolute value. Get rid of all the addition, subtraction, multiplication, division before and after the absolute value symbol. Step 2, determine if the absolute value is even possible. Which means once you isolate it, if it equals a negative number, is that even possible? Okay, now with inequalities, it's a little bit different. Okay, you got to look and make sure it's possible, but if it is, you got to make sure it's possible. Then you make your case 1, case 2, and you solve each case, and then you make your number lines. Okay? Then find the final answer.
Now, is this going to be both triangle things with the line under it, without the line under it?
Yep, and we're going to do an example. So you can either do this on your paper that you started, or you can do it on the paper that I just printed off. But here are the examples. Okay, so step 1, we have to isolate the absolute value. The only thing outside of that absolute value is what?
3.
3. How do I get rid of that 3?
Divide.
Yeah, divide both sides by 3. Now, I have the absolute value of y minus 9 is less than 9. Here's the only thing that you're probably going to forget. Okay, this is what you're probably going to forget. Now let me ask you a question. Case 1, okay, y minus 9 is going to be less than 9, right? Now case 2, what do we have to do to the 9? We have to make it what?
Negative.
Negative. However, when you make something negative, right, it's going to look like this. We have to make y minus 9 be the opposite, right? That's the same thing, the opposite, the negative. But in order to get rid of that negative, what do I do?
And?
Well, not add. This is negative 1 times. I could distribute it. What's another way to get rid of it? Couldn't I just divide both sides by? But when you divide by a negative, what must you do? You have to switch the sign. The negative, remember I said when you make case 1 is always the positive, case 2 is always the negative. Now usually we said, okay, it's just y minus 9, okay, is less than negative 9. However, here's what I want you to see. If you make this negative, what do you have to do to the sign? You have to, for case 2, when you make a negative, you must flip the sign. Now I don't care if you write it like this and then divide by negative 1 so you never forget to flip the sign, or if you just write it like this and then flip the sign. Either way, you can do it, and I'll do another example to show you both ways, okay? So I divide by negative 1, I have to flip the sign, and I get negative 9, so y minus 9, add 9, so y is greater than 0. So if I'm following my steps, I did case 1, I solved each case, make your number line, okay, so that we can...
So it's the same thing, we're just flipping the sign.
Correct.
Negative.
Oh, I forgot to solve case 1. I forgot to add 9 to both sides. So y is less than 18. So once I make this, I graph both of those inequalities. Is it going to be an and or an or?
4.
Well, let's graph it. Here's a 0, and here's 18. This one, y is less than 18. So I have an open dot, and it's going this way, correct? Or y is greater than 0, so I have an open dot, and it's going this way, so it's an and or an or graph. It's an and. Remember, when they hit each other, it's an and graph. They run into each other, so this is an and. Which means I can make it a compound inequality. I could put y in the middle. Remember, and graphs can be written like this. Or they can be written like this. Those are the same thing. You guys remember dusting off your brain from the weekend? Remember that? Okay, let's do another one. Oh, well here the first step is done for us. Oh, that's the same one. Okay, here, let's do this one. Okay, step 1, isolate the absolute value. Get rid of everything else except for the absolute value. So what do I have to do?
Divide by 1/4.
Well, not yet. First thing I want to do is subtract 2. So I'm going to subtract 2, and then I'm going to get 1/4 times the absolute value, x minus 3. Okay, this is going to get rid of this one. Less than -1.
50 times 4.
Now we're going to multiply both sides by 4. Are you ready? So now I'm going to multiply by 4 here and multiply by 4 here. These are going to cancel. I have the absolute value of x minus 3 is less than -4. Step 2, determine if the absolute value is even possible. Is this possible?
No.
No.
Can you have absolute value of x minus 3 is less than -4?
No.
Not possible. So for this one, you can say, oh, no solution, not going to work. It's not possible. Because whatever you put in here for x, it has to be greater than 0. Right? Because it's absolute value. It has to be 0 or greater. Okay? Let's do another one.
Did you keep these up on this?
I don't know. I might have. Okay, step 1, isolate the absolute value. So I have to do what? Get rid of this 3. Add 3 to both sides. So add 3 to both sides. And I have absolute value of x plus 5 divided by 3 is greater than 9. Now, is that possible?
Yeah.
Yes, it is. So now, case 1, case 2. Case 1, I have x plus 5 divided by 3 is greater than 9. Case 2, remember, what do I have to do when I do case 2?
Make it a negative.
Yes, you have to make it a negative or flip the sign. Don't forget. Whatever you need to do to remember that. When you negate an absolute value or an inequality, you have to flip the sign. So this one's going to become less than, but I have a negative sign. So x plus 5 divided by 3 is less than -9. Does everybody see how I flip the sign? Please, if you don't remember anything today, remember that. The second case, you have to flip the sign, or make the whole one side negative. And then when you divide by -1, flip the sign. Okay? And then solve each inequality. For this one, how do I get rid of that 3?
Multiply.
Yeah, multiply both sides by 3. They're just going to cancel out. So I have x plus 5 is greater than 27. Subtract 5. So I have x is greater than 22. Then solve the other side. Once again, multiply both sides by 3. So I have x plus 5 is less than -27. Subtract 5. So x is less than -30.
I have a question.
Yes.
Instead of starting all the way back, like where you started to the negative, could you start at -27? That x plus 5 is less than -27?
Like, instead of multiplying both sides by 3?
Yeah.
Well, no, you have to isolate the absolute value and make both cases.
Because I got the same answer as you, and that's all I did. I started from x plus 5 is less than -27.
I had to see what you did. Okay, but once we get to this point, now we graph it. Okay, once you get to this point, now you graph it. So I have x is greater than 22, but less than -32. Open dots. So do I have an and or graph?
No.
Does it go opposite or the same direction? So it goes this way, and this one goes this way. So if they're in opposite directions, what does that mean?
Or.
It's an or. So your answer is going to be or. That's your solution. Don't forget to put your and or in there. You can't just have both of them. You have to put and or. Or you can write it as a compound inequality if it's an and graph.
Can you take it up?
Was that? Yeah, sure. Okay, let me go come see what you did, Trey. Another example.
Holy crap.
First step, isolate the absolute value. So I have to
Subtract the 9.
subtract 9 first, and then I have 3 times the absolute value of 5. 5t minus 1 less than or equal to 14. Divide by 3. So I have the absolute value of 5t minus 1 less than or equal to 14 over 3. Absolute values isolated, is that possible to have that?
Yeah.
Yes, it is, because it's positive and it can be less than, it's fine. So now I can make my 2 cases. Case 1, okay, 5t minus 1 is less than or equal to 14 over 3. Or, case 2, 5t minus 1, what do I have to do?
Flip the sign.
Flip the sign in case 2. Greater than or equal to 14 over, negative 14 over 3. And solve. What do I have to do here first? Now this is fractions, don't get scared.
Add 1.
Yeah, I'm going to have to add 1 to both sides. But when I add 1, can't I just add 3 over 3 so that I have a common denominator? Isn't 3 divided by 3 just 1?
Yeah.
Yeah, so I'm just going to write it plus 3 over 3. It's the same thing, but then I can add it. This gives me 17 over 3. You see what I did there? I'm going to say that again. I have to add 1 to both sides, but instead of adding positive 1, I just put 3 over 3 because 3 divided by 3 is 1. Then I have a common denominator of 3, and I can just take 14 plus 3, and I got 17.
Where does this 3 over 3 come from?
What if I reduce 3 over 3? What does it reduce to?
I don't know.
3 divided by 3. How many 3's fit in 3?
3?
How many 3's fit into number 3?
Oh, 1.
Yeah, so 3 over 3 is just 1. What about 4 over 4? What's 4 over 4?
1.
1. What's x over x?
You have 3 over 4, 14 over 3.
Plus 3 over 3.
That way they have the same denominator.
I want, when you add fractions, they have to have the same denominator.
Okay.
Okay, so I made it 3 over 3 so I could add them. Does that make sense?
Okay.
Okay, so now I have 5t is less than or equal to, now I'm going to divide by 5 or multiply by the reciprocal. Why would I want to multiply by the reciprocal instead of dividing by 5?
To make it a fraction.
To make it a fraction. So I'm going to multiply by 1/5. That way when I go over here, I have it's easier. It's not a fraction divided by a fraction. Okay, so these are going to cancel unless with t is less than or equal to. You have fractions, marry the tops, marry the bottoms. So I have 17 over 15. 17 times 1 is 17, 3 times 5 is 15. Okay? I know it's a lot with fractions, but I did one hard one. Okay, so you guys have one hard one. Okay, now let's do the next one. Add 1 to both sides. Now, Bear, what do I want to add so I have a common denominator? What can I put on that?
3.
Yeah, 3 over 3, right?
Yeah.
That's the same thing as 1, so I have 5t is greater than or equal to negative 14 plus 3. Negative 11. Then divide by 5 or multiply by the reciprocal. And when you have fractions and you're multiplying, what do? Marry the top, marry the bottom. So I have negative 11 over 15. Now we have to graph it and decide if and or goes in there. Get your graph out. I have, here's 0. 17 over 15 is just a little bit over 1, so I'm just going to put 17 over 15 here. And negative 11/15 is a little bit less than 1. Negative 1, excuse me. Negative 11/15. I have closed dots on both of them. And which way are they going? This one's going to go which way?
To the left.
This one right here?
Oh.
Yep, look at the arrow, look where it's pointing. It's going to go this way. And this one is going to go this way, so there's an and or graph.
And.
It's an and, so you can write it with an and in here. Or you can, if an and graph can also be written as a compound inequality, right?
Mm-hmm.
So write it as a compound inequality. So I have, put the bigger number over here, 17 over 15, and then I have negative 11 over 15 here. You can write it either way. You can put and in the middle, or you can write it like this. I don't care. As long as you understand that a graph that connects in the middle is an and graph. Okay? Close dots because it's used. Any questions? Can you do this again? On your homework? Yeah? Okay, let's give it a try.